Hey, what is going on? It is Friday, March 18th, 2022, and I am here to do another lead code problem. Welcome to Coding with Shaf, where you get your code and we are the Shaf. Okay, whatever that meant. All right, let's do a easy lead code problem today called minimum absolute difference. Okay, so this is a well-liked problem. It is apparently it has 1,424 likes to 58 dislikes. So I'm gonna like this problem. Okay, cool. Give it a little bit more liking. I like this problem because it's a simple-looking problem. I mean, simple looking in the sense that the problem statement is straightforward and we're dealing with one array. We don't have a bunch of conditions and whatnot, and sometimes it's good to be able to do these problems pretty efficiently. All right, especially if you're in an interview and you get something like this, you want to be able to pull out the quick mathematics from your brain and figure out how to put a solution to this together pretty fast if you can, using your logic. So let's see the problem statement. Given an array of distinct integers ARR, find all pairs of elements with the minimum absolute difference of any two elements. Return a list of pairs in ascending order with respect to pairs. Remember, ascending order. Each pair A, B follows A, comma B are from ARR. A is less than B. These are important. And B minus A equals the minimum absolute difference of any two elements in the array. Okay, so first thing you want to think about, right? Okay, so what is the minimum absolute difference, right? Let's look at these examples. If we have 4, 2, 1, 3, the output is 1, 2, 3, 4. Okay, so the minimum absolute difference here. Okay, let's go through all the differences, right? So logically, just first off the top of your head, what is something you could do? You could go through each of the pairs of differences, each of the pairs of elements, so where the one element is larger than the other element, and look at the minimum difference. So you have 4 to 2, 4 minus 2 is 2, 4 minus 1 is 3, 4 minus 3 is 1. So the minimum difference in this array so far between all of these elements is 1. We have to check the iteration of all of these elements, right? So the difference between 2 and 1, and difference between 2 and 1, and the 2 and 3 is 1, right? That's the minimum absolute difference there. So far it looks like 1 is the minimum absolute difference of the entire array, and then the difference between 3 and 1 is 2, the difference between 3 and 2 is 1, and the difference between 3 and 4 is 1. Okay, so and the absolute difference. And so it looks like the minimum absolute difference is 1. So basically we're going to count 4 and 3, 2 and 1, 3 and 2. Okay, and so the thing is, the algorithm I outlined was kind of like a brute force-ish algorithm of O of n squared time, where I'm checking each of these pairs, right? The question is, there's two problems with this. First, it's intuitively it's probably slow, right? Why would we want to check all of these pairs, right? We're looking for a minimum difference between the pairs. The ordering doesn't necessarily, at least in the sense of where we're looking for differences, doesn't matter, right? Like, we're just looking for the minimum difference. Okay, so that's sort of a hint number one, right, or something. And the other thing is that, remember, the statement says that A has to be less than B. B minus A is equal to minimum difference, absolute difference between any two of the elements in their ARR. So you have to, this is important because B is less than A. See, in this, you won't necessarily appreciate it from this array here, but in this array, you see we have negative numbers, okay? So remember, the minimum absolute difference, right, will essentially differ, right? Because if you have 10, for example, 10 minus, the absolute value of 10 minus 23 is 13, right? But if you have the absolute value of 23 minus -10, right? Um, you have 33. Okay, so you have to, the ordering matters, right? That's problem number two. So we have to also account for ordering of the elements relative to each other, and such that the numbers are descending, right? A and B. And then the final issue, there's another issue, right? The final issue is that when going through this array, it's easy to get duplicates, right? Like, because if we're looking at 4 to 2, 2 to the 2 minus 1, 3 minus 2, etc., then we're looking at also the reverse, 1 minus 2. So anyway, the point is, let's just get to the code. That's enough explanation of what we have to do. So what can we do here, right? So there's instead of brute force solving it with a n squared nested loop, let's do something different. Integer minus max value. Okay, so first I'm gonna keep my minimum difference, right? And so remember, I'm just looking for the minimum absolute difference. The easiest way to find a minimum difference between two things is to essentially order them, right? Because if the closest two elements, if all the elements are sorted, are going to be right next to each other. So let's sort this array, right? Because there's no other way to arrange those elements, right? Such that the elements will give you the minimum difference right away. And let's go through this solution. Let's figure out how to do this. So what I essentially want to do, all I need to do to calculate the minimum difference here, absolute difference between the rightmost and leftmost element, is just go through the array at this point, right? Because I have the answer right in front of me. I don't have to check every element pair. So length, let's try this. We're going to do a for loop. I'm starting at 1, I++. And so I'm going to calculate a difference, right? And this is just the difference of the minimum. This is the absolute difference for just the pair, right? Okay, and this will be between the two pairs of items. This will be the smallest difference possible, right? Not the minimum difference for the entire array, which is something we're going to check. And I will show you how to do this. I believe this will be right. So let's say that we want to find the minimum difference between all the elements in the array. So absolute difference. So first, if we find a difference that's less than the minimum difference we found so far, all we have to do is add that to the array. Okay. Array less than. This is kind of like how I'm just adding the pair, and remember its pair is b minus a, so it's in descending order. So this is nice because all the elements are already sorted, so I don't have to iterate again and have like a potential duplicate there, because I'm having to consider the ordering of the elements from left to right and right to left. This will be always such that a is less than b and b minus a is the minimum difference. Okay, so this will add. So now what do? Whenever we have a minimum difference that's less than or equal to element, we add this pair, right? But one thing we have to consider is that we might find a smaller difference, right? So if we find a difference that's smaller, right? If we find a difference that's smaller, then we have to get rid of result not clear, because result was my I forgot to add my result array. List. Okay, so this is my result array. So the array that you're going to return to the caller is going to be cleared, because all the other previous elements are going to be irrelevant at this point, because we found a minimum difference that's smaller, and here we're going to reassign the minimum difference that's smaller, and we add the element anyway, right? Because this element still has to be accounted for, even though it has a smaller minimum, especially since it has a smaller minimum difference, strictly smaller. Okay, return result. Okay, so let's see how this works. I'm going to do the test array. Okay, accepted, right? And then submit the whole thing. Okay, cool. And not bad. Okay, so I'm gonna do this, and I'm going to write a little description. So that's pretty much it. Minimum difference. If you like this video, like, subscribe, comment, and yeah, I will see you later.